So this is an explanation of how I approached question 6 on the practice test for the Proofs of Theorems unit. So this question says, the figure shows triangle ABC with medians AF, BD, and CE. Segment AF is extended to H in such a way that segment GH is congruent to segment AG. And then it has a figure. So my first step is that I'm going to construct that figure on my paper so that I can start marking things down as I figure them out. So I start by building a triangle ABC. I'm deliberately making it not any particular special kind of triangle. So I'm making sure all my side lengths are a little different from each other and that I'm not like making right angles and that sort of thing. And I'm doing that because I don't want to accidentally trick myself into finding things that wouldn't be true in general but just look like they're probably true visually, because that is an easy way to outsmart yourself with a construction. And I'm going to be careful to only trust things that I've marked are equal rather than just like eyeballing them and going, they look pretty equal, because that is another way you can really trick yourself with this stuff. So this is triangle ABC. And because it wants to have medians, the next thing I need to do is construct the medians. And so for this, I need to go back to my construction tools. And I'm going to use a compass because I need to find the middle of each of these segments. So that would be the middle of that segment, and I'll draw that in pink as point D, and then I'll construct that median. And since that is a midpoint, this is going to be congruent to this, and I'm marking that in the same pink I used to construct this, because that's going to help me keep track of what I'm doing as I see where things come from. It's just kind of a way of taking notes while you're doing things to use a bunch of different colors. You don't have to, but I find that it makes my life easier if I do. So now I'll do the same thing on side BD. Except that I didn't leave my compass wide enough, so I'm going to fix that, because that is a thing that one has to do. And then I can do this one, and I will do this one in orange, and that one will be E, and that will construct median CE. And that means that this is congruent to this, because that is the midpoint of that segment. Similarly, I will construct F over here. And I'm making my compass narrower here so that I can make a smaller set of arcs. It would work even if I didn't do that, but I would like to leave less work for myself. And this one I will do in green. That will be point F. That will be median AF. And I recommend that you also construct this, so if you need to pause the video long enough to get that done, go ahead. I'm also going to briefly mute my phone because I didn't do that before starting this video, and that is super awesome to discover in the middle of a video. That has now been accomplished, and I can go on to the other thing that they told me to construct, which is that segment AF is extended to H in such a way that GH is congruent to segment AG. So that means that I'm going to construct just a little guideline here in pencil that's an extension of AF out as far as I might possibly need, and then, oh, and I need to mark mark G on here, which is where all of my medians intersect, because medians always intersect at a single point. So now I will measure AG and copy that segment. Let's see here. There we go, that is AG. So that is where point H will go. It's right down there. I will once again use another color for this so that I can kind of remember where things came from. And I will draw that line in blue here and mark that this is congruent to this. And then I will connect these just because they're in my diagram and they're in some of my answer choices. And so now I've finished making my figure, which I think I need to zoom out a little bit so you can see. So I've finished making my figure. And now I can just kind of look and see what I can find, and I forgot to mark in these, so I will do that now. Those are because F is the midpoint of BC. And so I'm just kind of looking for relationships, and I'm looking at the things that I might want to find. And I try to see if any of these are related in a way that might make sense. So let's see here. GF is right here, and I want to know if I can think of a reason why that would be congruent to EG. I don't see any particular reason why GF and EG would be congruent. They don't look congruent. So I'm going to throw that one out for now, come back to it later if none of the other ones make sense either. Segment GF is half the length of segment EB. I don't see any reason why that would be true. It doesn't look particularly true, so I'm going to go through the rest of my multiple choice options and come back and try to make that one work if nothing else works. Segment GD, where's GD? There it is congruent to segment EG. So again, they don't look particularly congruent. This one looks shorter. I don't see any reason here, like this length isn't the same as this length. I'm not seeing a good argument for why they would be. If I get stumped, I'll come back to it. Segment GD is half the length of HC. That looks really plausible, so that's the one I'm going to start trying to figure out. Can I come up with a reason? What kind of relationships can I build here? And what I notice is D would be a midpoint here. That I have this big triangle here that I've constructed. And the DG would be a midpoint of it because it's halfway between AH, it's halfway between AC, so this has to be the midpoint. So that means, and I'll mark these in purple, this has to be parallel to this, and I'm guessing I can make some other interesting arguments. Because what I want to know is, oh, I can just use the midsegment of a triangle theorem, because a segment connecting the midpoints of two sides of a triangle is parallel to the third side, and its length is equal to half the length of the third side. So because this is the midsegment, it has to be half that length. And that's how I can figure out that it should be that segment GD is half the length of segment HC.